Hello guys, welcome. In today's video, I'm going to talk about real-time operating systems. And since I cannot talk about everything in just one video, and I'm not interested into reinventing the wheel, you can go check out the DigiKey Free Auto series of videos made by Sean Himmel. He breaks down everything you need to know about real-time operating systems in a very interesting and uh, elaborate way. What I propose in this video is a simple example for people who already have the very basic knowledge of an RTOS and just are looking for some more examples. In my example, I have three tasks and an interrupt service routine, and the tasks have different level of priorities, high, low, and medium priority. Task 1 and 2 have some shared resources that I protect using a mutex. And task 3 is doing its own thing on the side. Now the thing is, for task 1 to take the mutex, it has to receive a semaphore from the interrupt service routine. And whenever you're using an interrupt, you want to use a semaphore rather than a mutex. Semaphores are more of a signaling mechanism where uh, mutexes are more of a protection mechanism. And when you're using a mutex, you have priority inheritance, which means if task 1 needs a mutex and it's held by task 2, which is a low priority task, the task 3, which has a higher priority than task 2, won't be able to preempt that task 2 because the priority of task 2 is going to rise to the same level as the priority of task 1. So task 2 will go from low priority to high priority when it's holding the mutex and task 1 is needing the mutex. So that's called priority inheritance. And like that, task 1 don't have to wait for task 3 to do something. It can immediately have access to the mutex as soon as task 2 finishes. I'm using CMC's Autos V2 API for my example. Here are the different tasks with the mutex and semaphore. Here is the global variable that's shared between task 1 and 2, buffer to store the message I'm printing out, and here is the value of my sensor. I'm using a photoresistor, so the initial value here is 1000. And let's go down to task 1. So what's going on in task 1? As you can see here, it's very verbose. I have all these messages just to know, what's going on in during the execution of the task. And here you have the semaphore that's being acquired, and after that is the mutex that's acquired. So here is a random function. I'm using a random function to have a delay that changes. So here's the formula if you're interested in. So here my random function varies between 500 milliseconds and 1000 milliseconds. So in task 1, as a shared resource, I have an LED that I'm turning on, and I am incrementing the global variable that we've seen earlier. And then after doing that, I release the mutex. And in task 2, once task 2 acquires the mutex, it turns off the LED and decrements the value. And task 3 is just it's toggling a different LED, it's doing its thing. So the code for the most part is really going to be between task 2 and task 3. And only if the condition here in the ISR is true, then the semaphore is going to be released and task one will be able to modify the the critical section, the shared resources. And here I'm just using timer 3 to relaunch my ADC value, and I'm using timer 11 for the sysdig, for the tick counts, because when you're using an RTOS, I've seen that it's recommended to not use the sysdig. You should use a different timer. Right now, task 3 is blinking the blue LED. And let me open PuTTY. And you can see that task 2 is also decrementing the global variable. And if I place my finger on the photoresistor, the other LED will turn on. There will be an incrementation of the global variable, and it's going to turn on the LED, and then task 2 is going to turn off the green LED. This is it for today's video. You can find the code in the description. Thank you for watching and see you next time.